In this video, we're going to look at the most common application of these exponential functions that we've been working with for the last few learning objectives. All right, one thing to note about this learning objective is you need a calculator. So a calculator is going to be required for all the problems you need to do in this learning objective. All right, so first of all, in order to talk about this application of exponentials, we need to kind of understand what's going on. All right, so what is interest? All right, when you keep money in a bank, the bank then kind of takes that money that you have sitting there and loans it out to other people. So I put in $500, which, okay, let's use a bigger number because they're banks. All right, I put in $5 million and the bank is like, okay, now we have this $5 million we're holding. Let's loan it to this other person who's looking for $1 million loan and they'll pay us back. All right, so that's how banks make their money. All right, so in order to loan money from a bank, they're going to require you to pay an interest rate, which means a little percentage of what you're borrowing, you have to pay extra. All right, so this just means that the bank is making a little bit on traction. So if I borrow $1 million today, over the course of this loan, because I'm paying a little bit extra in interest, maybe at the end of the day, I actually pay back $1.1 million for the loan. So the bank just made $100,000. All right, so this interest rate is how the bank makes the money. And one nice thing they do is because they're loaning out technically your money that they have sitting in your account, is they're going to say thank you for using our bank, and what they do is give you a small return on the money. So they actually give you your own interest rate for just keeping your money in the bank. All right, so the bank's charging you extra if you're taking out money, but if you have money in the bank, they're actually giving you a little bit back. All right, of course, this number, the amount they're charging might be like 5%, and the amount they're giving you is going to be 1%. So that difference is where they're making their own money as profit. This is the way banks work. These interest rates are all over the place, and you see it whenever there's like a car commercial and stuff like that as well. But there's a mathematical formula to calculate the interest you get from something. We're going to pretend in this scenario as we're the people that have the money in the bank. We're not borrowing the money. That tends to get a little bit complicated because you're paying it back in installments and everything like that. So we're just going to look at, we put our money in the bank and leave it there. And again, the bank is giving us kind of a return, a thank you every single year or something like that on that money. All right, so this is the formula. This is not a formula you have to have memorized, so don't worry about memorizing this formula, but we do need to know what everything is. All right, so the first letter is A. That's the final amount of money we're going to have at the end of this process. Capital P is known as the principal. That's the initial amount I put into the bank. All right, lowercase r is the interest rate. Written as a decimal, so if it's 5%, I'm not writing a 5 here, I'm writing a 0.05. If you had a 5 there, that means you get a lot of money really quickly. N is twice in the equation. That's the number of times compounded per year. So basically it just means how often are they giving you that little bonus. If they just give it to you at the end of every year, this number would be 1. If they're giving you a tiny, tiny little bonus every single day, that would be 365. All right, so this number will change depending on kind of how often they're giving you a little thank you. And the last one is T, is the amount of time. And generally, because it's compounded per year, this is also in years. All right, so all we can really do right now is just use this formula and plug stuff in. Again, you have to use a calculator. So you put $2,000 in Bank of America. They're going to give you 2% compounded monthly, and you're going to keep your money there for 3 years. How much money you're going to have. So we want to know our final amount. Our principal is $2,000. That's the original amount we put in. All right, 1 plus our interest rate goes on the top. And again, this is a percentage. We change it to a decimal, so 0.02. Compounded monthly. So if I'm doing it every month, they're paying me 12 times a year because there's 12 months. So I'm going to put 12 there and a 12 there. And I'm waiting for 3 years, so my time is 3. All right, so all of this, I'm just going to type in a calculator. All right, just make sure you're careful when you're typing in, especially with this fraction inside the parentheses. But if you're using something like Desmos, as long as it looks like how you write it, then it should be good. All right, so it's going to take me a second to type in. 0.02 divided by 12. All right, and when I do that, I get $2,123. And it makes sense because it's money around the 2 decimal places, so 57. Right. So after 3 years of just leaving your money in that bank at 2% interest, you basically got $123.57 for just leaving your money there. So that's kind of the thank you the bank is giving you for using them, and basically at the same time allowing them to loan out your money. All right, so one thing you might notice if you do some of these calculations is more compounding is better. If they compound daily, that's better than compounding monthly. If they compound monthly, that's better than doing it once a year, because you're getting these small bits of extra interest more often. All right, so compounding more often is going to be better for you. And here's kind of a simple case of what's going to happen. So to make the numbers really simple, we're going to put a single dollar in our bank. All right, so our principal is 1. We're going to get 100% interest rate. That's unheard of, but 100% turns into a 1, so it also makes it easy. And you're going to put it in for just a single year. All right, so this would be our formula. All right, our principal is 1, so that's just out there. All right, we don't need to write it. Our interest rate is 1. Our time is 1. All right, and now it's going to change based on the number of times we compound per year. So if we compound annually, that means we only do it once. And if we just have 100% interest, we end with $2. Semi-annually means twice. You can see how much I get: quarterly, monthly, daily, hourly. So there's 8,760 hours in a year. And that's how much you have. Once every minute, that's how many minutes are in the year. That's how many seconds are in the year. All right, so you would think as I go to every single second, like I'm adding these little bits of money so often that I basically get infinite money. But what you can see on the right-hand side is there's kind of a place where it stops. So it goes up to 2.7, and then 2.718, and it doesn't really get more than that, and 2.782, and it doesn't really get more than that. So there's kind of this leveling off point that happens no matter how much I compound my interest. And this is actually a really important mathematical concept, that there's this leveling off point, and it comes up so often in other situations and other equations and everything that we give it and we call it E. Okay. So just like every single time you see pi is always going to be about 3.14. Sorry, 3.159, that's as far as I have pi memorized. All right, but pi is just a symbol that represents a number. Now E is going to be the same thing. It's this symbol that represents this number that's about 2.718. But the nice thing with this number E is once we have this number E, we can simplify some of our formulas. And it turns out if we're compounding continuously, so continuously means you're getting little tiny bonuses as often as possible, we're going to get this formula for interest. All right, so P is still going to be our principal, R is still the interest rate, T is still time, but E is now that number 2.718. All right, most calculators have just an E button that'll give you that, just like a pi button. All right, so John and Paul both invest $1,000. John invests in a 3% return compounded quarterly. Paul invests in 2.5% compounded continuously. All right, who's going to have more money after 5 years? All right, so let's do John first. John's amount, he's investing $1,000 as his principal. All right, this is not continuously, so we have to use the original formula that we had. All right, his percentage is 0.03. Quarterly means it happens 4 times a year. That goes in the formula twice, and it's after 5 years, so our time is 5. All right, so that's the formula for John's amount of money. Paul's is being compounded continuously, so we're going to use the new formula, P e to the RT. So our principal is still 100. E is the base of an exponential. The rate is 2.5%. If I move that decimal point over 2, I get 0.025, and for 5 years. All right, so let's do John first. Again, just plug all this into a calculator. 1,000. 4 times 5. Right, so after all that, putting all that in the calculator, I get 1161.18. So John is making, basically in that 5 years, an extra $161. All right, what about Paul? Now I gotta type in that equation. E raised to the 0.025 times 5. And after all that, I get 1133 0.15. Right. So after 5 years, Paul makes about $133. All right, so who made more money? John made more money. All right, he had a bigger percentage. So it turns out the percentage is more important than how many times you compound. All right, they were pretty close at the end of the day. All right, there's about a $30 difference. All right, but having a bigger percentage is going to be more useful. All right, but you can see our two different formulas. All right, if it's compounded some normal number of times, like 4, you use this left-hand formula. If it's compounded continuously, then you use this new formula with that E, that special number in it. All right, so go ahead and try this one on your own. You invest $25,000 when you turn 20. You get a 5% return, compounded continuously. All right, how much money are you going to have on your 60th birthday? All right, we're compounding continuously, so you should have used the E equation. It's our principal is 25,000. That's what we started with. All right, we have a 5% interest rate. And if I'm 20 and I'm going to my 60th birthday, that means there's in there for 40 years. All right, so you put all that in the calculator and so you get 184,000. All right, so putting your money in the bank for a long time is really beneficial. So I started with 25,000 and I ended with 184,000. All right, so to show mastery of this topic, you're going to complete problems on delta math. All right, again, you're going to need a calculator to do them, but basically use the formulas that we looked at in this video. You don't have to worry about memorizing. Just make sure you're plugging things in the correct place and figuring out the answers for the delta math problems.